Alright, Alex, I'm going to go ahead and explain how to do the limit as x approaches negative infinity of the square root of 9x to the 6th minus x all over x cubed plus 7. I'm going to actually send you two videos because there's two different ways of solving this. I'm going to explain the way I solved it last night. The key to that is knowing that the absolute value of x is a piecewise function where you're going to use x if x is greater than or equal to 0, and you're going to use negative x if your x is less than 0. So when we get an absolute value, because we're doing the limit as x is approaching negative infinity, we're going to have to use the negative x. And that's only because we're doing the limit as x approaches negative infinity. Since my x equals negative infinity, I have to use the negative x. So that's going to be key later on after we do some algebra here. All right, so first thing I want to do is I'm just going to factor out x to the 6th on top, and that's going to give me the square root of x to the 6th times 9 minus x over x to the 6th. And on the bottom, I'm going to factor out an x cubed. And that's going to give me that's going to give me 1 plus 7 over x cubed. And of course, this is still the limit as x approaches negative infinity. The reason why I did that is because I did see this x to the 6th here, and I know that this square root, if I could take the square root of x to the 6th, I get this x cubed, so I can get rid of it. It's kind of a clever little trick of manipulating with algebra, but you also have to know your square root rules here, because you're multiplying under the same square root. You can rewrite this as x to the 6th times the square root of 9 minus 1 over x to the 5th after we reduce the fraction, all over x cubed times 1 plus 7 over x cubed. And of course, this has still got the limit as x approaches negative infinity. From there, with the square root, the square root of x to the 6th, well, x to the 6th is going to be a positive number, but it could be negative because a negative to the 6th power is always going to be positive. Because of that square, when you take the square root of x to the 6th power, I want to get the absolute value of x cubed, because x cubed could be a negative number, times the square root of 9 minus 1 over x to the 5th, all over x cubed, times 1 plus 7 over x cubed. And of course, this is still with our limits. All right, from here, all I want to do, since I have the absolute value, I know I have to use the negative, so this is going to become negative x cubed square root of 9 minus 1 over x to the 5th divided by x cubed 1 plus 7 over x cubed. Well, these x cubes cancel out. Of course, I still have my limit here because I haven't plugged in my infinity. And that's going to give me the limit as x approaches negative infinity of the square root of 9 minus 1 over x to the 5th divided by 1 plus 7 x cubed. Now when I plug in my infinities, I'm going to get the square root, I forgot my negative. This negative square root of 9 minus 1 over negative infinity to the 5th power over 1 plus 7 over negative infinity to the 3rd power, which ends up being just negative 9 minus 0 over 1 plus 0, which gives me negative square root of 9, which is negative 3. It's not that easy of a problem. It's a clever little way of actually solving it. So I want to send this video to you, and I want to solve it a different way, and maybe you'll understand the other way better.